Okay, remember that if we are multiplying, right, what we're going to do is we're going to add the exponents. Okay, so this is going to be 2 to the 4 plus 0, okay, which is just 2 to the 4th. The next one, 2, okay, to the power of 4 plus a negative, plus, I was thinking ahead, plus a negative 1. Okay, and that's going to be 2 to the 3rd. The next one is 2 to the 4th plus a negative 3 is going to equal 2 to the 1st. Okay, and then the next one is going to be 2 to the 0 power. Okay, so for the next one, we see that the structure has a volume of 1,200 cubic centimeters, and it doubles each year. Okay, so write an equation in the form of y equals a plus b to the t. All right, so here y is equal to 1,200. Okay, so that's the initial number. Oh, that's horrible. Okay, volume. And then we're going to have times. Now it's going to double every t years. Okay, so find the volume of the coral when t equals each of these years. I'm going to go ahead and copy down the table of this. Okay, so I put in the table here, and just remember that this number right here, okay, when t equals 0, that's the initial. Okay, and then what we can do is we can plug in, right, our time to into this equation, and then it will give us the rest of these values. Okay, but what does it mean in the situation when t is negative 2? Okay, so what this is 2 years before. Okay, the scientist took the measurement of 1,200 cubic centimeters. Actually, let's do it this way. Let's write it out. Okay, in a certain year, the volume of the coral is 37.5 cubic centimeters. Which year is this? And explain your reasoning. Okay, for this one, we need to remember about our negative exponents. Okay, and so if we have y equals 1,200 times 2, now we see that it is decreasing, right, when we go to our negative time. So I'm just going to go ahead and guess a number. Okay, we'll do 6. All right, and so here we're going to have y is equal, this is negative 6. So what happens, remember, is when we have a negative exponent, it's going to bring that number down. Okay, and so now we have 1,200 divided by 64. Okay, and this is going to be, 1,200 divided by 64. This is going to be 18.75. Okay, so a little bit too much. So let's go to the 5th. Let's go 5 years back. So this is y equals 1200 times 2 to the negative 5. Okay, so remember, this is going to be y equals 1200, right, to 2 to the 5th. Okay, and so this is going to give us our 37.5. Okay, so we are going back 5 years. Okay, when t is negative 5. Okay, let's look at the next one. Windows of graphs. All right, so we have this 3 students use graphing technology, okay, to represents the volume of coral as a function of time. Okay, so remember, function of time is going to be on our x-axis, okay, and then the volume of coral is our y. Okay, so for each graph, we're going to do each one of these questions. Okay? All right, so let me take a second to write these down. Okay, so I just wanted to write these down and take a quick look. So the window is too small for A, right? Both horizontal and vertical directions, so only 2 points are visible. Okay, we can't see anymore, so we don't have enough to tell what's actually happening on the graph. For B, the vertical dimension of the graphing window is too large. Okay, so if you look here, it's like, what, 500,000 and then a million. Okay, so it looks like the points for the first 5 years are like 0. Okay, but they might not be. So when we scale everything down, C is the most useful one. Okay, because we can see the overall pattern from year to year. Having minor horizontal grid lines at a smaller interval may help us better approximate the output values of each point. Okay, and so let's take a look here. Now, describe how you would change it. Okay, so go ahead and do that, and then see if you can use graphing technology, okay, for number 3, all right? All right, let's go down to the next one. 7.4, measuring meds. All right, so we're going to take a look at the question and the table on the right-hand side. Okay, so for the first question here, A, right, is going to be the amount of medicine at 0 hours, okay? So B is equal to 1/2, okay, and A is equal to 100. All right. Find the amounts of medicine in the patient's body when t is -1 and -3, and then record them in the table. Okay, so over here, -1, -3, okay, and then, whoops, let's do it this way, 200, and then 800. Okay, and so if you see this, this is doubling, right? This is doubling. This is doubling. Then there'd be a double and then a double, all right? And that's going to give us the 800. So what do t equals 0 and t equal 3 mean in this context? So t equals 0 means the doctor did the first blood test. Oh, the time, sorry. The time the doctor did the first blood test. Okay. And then t equals -3 means 3 hours before the first blood test. Okay, blood test. All right, number 3, the medicine was taken when t is -5, assuming the person did not have any of the medicine in her body beforehand. How much medication did the patient take? Okay, so this is going to be 3,200 milligrams. Okay, and this is t is -5. So here, each hour, this is cut in half. And after being halved, five times, it leaves 100 milligrams, which is the amount of medication in the person's body when t equals 0. So let's take a look at that. We have our equation up here. Okay, and so let's go ahead and write it. M is equal to, we're going to go ahead and substitute our values. So 100 at t equals 0. Okay, and then here we have -5. All right, so what we're going to do here is when you have negative exponent, remember we're going to change the position of our base. Okay, so what's going to happen is this, it's going to be 100 times 2 to the 5th. Okay, and when you do this, it's going to end up being 3,200. Okay, and so that's how we're going to get the answer to that. All right, plot the points whose coordinates are shown in the table. Make sure to draw a label, tick marks on the axes. Okay, so I went ahead and did this for you. Sorry, that line is so horrible, but it's the best I could do. All right, so based on your graph, when do you think the patient will have 500 milligrams, okay, and no medicine remaining in the body? Okay, so this is just going to be pretty much estimating, right? And so we're looking for 500 milligrams. Okay, and so that's going to be about here, and then we're going to come down. All right, so what we can say here is this will be between 2 and 3 hours before the first blood test. Okay, and then what do we think about no blood? So this one, it's going to be sometime after 10 hours. the amount of medicine falls below 0.1 milligrams after about that point. Okay, and you could do the calculations if you want to. Okay, let's take a look at the Are You Ready for More? Okay, so for this question, let's go ahead and break the first one down. Okay, so I'm going to have 1 divided by 1 minus, okay, remember that 2 to the negative 10th, that's going to bring it down to, okay, to the 10th. All right, so now we got rid of that exponent. So now we need to solve this. Okay, so now we're going to have 1 divided by 1 minus 1 divided by, okay, so 2 to the 10th is going to be 1024. Okay, but now we need to do this. Okay, I'm going to do it in a different color just so we don't lose track of it. Let's do this. Okay, so now I'm going to have 1 divided by 1 minus, okay, so 1 divided by 1024 is equal to like 0.12397. Okay, so a really small number. Okay, so basically we have 1 divided by something really, really, really close to 1. Okay, and so this one is close to 1. Okay, so here we're just kind of playing around with the exponents and making sure that we know what to do if they're negative. Okay, so for the next one, okay, remember what we can do here is, let's see, if we have 2 to the 10th divided by 2 to the 10th plus 1, okay, if we do 2 to the 10th, okay, that's going to be 1024. Okay, so 1024 up top. Okay, divided by, this is 1024 plus 1. Okay, and so what we have is we have 1024 divided by 1025. And then when we do that, okay, we're going to get like 0.999. Okay, so really close to 1 again. Okay? All right, so now let's look at the next one. Okay, so for this one, we're going to go ahead and again, let's substitute some values here. So remember, 2 to the negative 10th, we're going to write that as 1 divided by 2, right, to the 10th. And this is going to be divided by 2 to the 10th plus 1. Okay, so now let's go ahead and look at the top one. All right, so we have, actually let's evaluate 2 to the 10th. We know that 2 to the 10th is equal to 1024. Okay, so that's something that we saw earlier. All right, so now let's go ahead and rewrite that as 1 divided by 1024, okay, divided by, now we know 1024 plus 1, okay, which is 1025, okay? All right, so now we need to do our next step. I'm going to do it over here. Let's just do 1 divided by 1024 divided by 1025. Okay, so now let's take a look at this one. So remember, I'm going to come over here. Okay, sorry, actually, let me go down. All right, so now remember, for our division of fractions, I'm going to have 1 divided by 1024 times, remember the reciprocal, okay, 1 divided by 1025. Okay, this is going to give me 1 divided by 100 and 1,000,000, hold on, let me just write it down, 1048,576. Okay, so 1 divided by 1,000,000, okay, something, and so when we do that, let's get out our calculator, 1 divided by, oops, 1 divided by 1,048,576 is equal to like point, oh boy, 0.0000000, I think like 953. Okay, so this right here is our answer, and so this is really, really, really close to 0. Okay, so this one is close to 0. Oh, sorry, close to 1. This is close to 0. Okay, for our next one, let's go ahead and do that. I think it's going to be pretty much similar. So my 1 minus, okay, now we're going to have 1 divided by 1024 divided by 1024. Okay, and so now we're going to have, let's see, 1025, sorry, 1023, okay, divided by 1024, all of that divided by 1024. Okay, so again, sorry, that's 1024. Our top number is going to be really close. Let's go ahead and do it. 1023 divided by 1024. Okay, that's going to be like close to 1. So let's go ahead and put 1 divided by 1024. Okay, and again, we are at a very, very small number, 0.12397. Okay, so again, this is going to be close to 0. Okay, and then let's take a look at this one. So I'm going to have 2 to the 10th, which is 1024 plus 1. So I have 1025 divided by 1, okay, divided by 1024. Okay, so remember that is 1025 over 1 times 1024 over 1. Okay, and so here we're going to have 1024 times 1024, sorry, let me redo that, times 1025. Now we're looking at 1,048,576. Okay, so this is much bigger than 1. Okay, so that was just kind of a review of our exponent rules. Remember, always look at the summary.